So let's sort of take stock of where we are because we've looked at a bunch of active record things. When we explained active record, we said it's this package of behaviors that your models can inherit by inheriting from a class called application record. We could sort of think of it as that's how models get connected to the database. And it means that a model instance knows how to do the database operations corresponding to create, read, update, and delete. Of course, at some level, there must be SQL queries being generated that do all that work. And you can, in fact, if you wish, inspect what those queries are. You can even do calls where you construct the query yourself. But most of the time, that's not what you want, because as we showed, you can do things like chaining together wheres and lazy evaluation so that the query doesn't actually happen until the first time that you need part of the result. Rails is almost certainly going to do a better job of synthesizing and optimizing those queries than you are, assuming that you don't write the query in a sort of brain-dead way. Convention over configuration. Once you name your model, and that consists of just saying class whatever and inherit from application record, that is enough to tell active record what the database table is going to be called. By looking in the database at the table and inspecting the names of the columns and the types of the columns, active record can infer what the names and types of the attributes are corresponding to your model. And so when you're bringing things back and forth between the database and the Ruby world, it can do all of the translations. For example, in my little live coding demo, when I tried to set the release date of a movie, I just set it to something that looked like it was probably a human readable date. And you can be pretty assured that if you looked in the actual database field, what you would see for the date is something that follows some very strict format that the database uses. But I didn't have to worry about that because Active Record has already inferred that because in the database, that column is of type date, then whatever I want to store in that column, Active Record will basically try to convert it so that it's of the right type. And conversely, when I read something from the database, when I read a model that has as one of its attributes a date kind of value, it will be converted into a Ruby date or datetime object, which has a whole bunch of useful behaviors that allow you to manipulate dates and subtract dates and stuff like that, right? So that's why it's a leaky abstraction, but it is a very, very good abstraction. It really tries to make the database side of the world do all the databasey things, but once the object has sort of crossed the magic line into the Ruby side of the world, it behaves in all of the Rubyistic ways that you would expect. It quacks the way that you expect it to quack for being a Ruby object as opposed to something that began life in a database somewhere. We also saw that that's enough for Active Record to create getters and setters, and that's where some of these behaviors are implemented, of essentially automatically managing some of these conversions for you, but always remembering that the object in memory is not identical to a row in a database. It is, in some sense, a mirror image of it, or like a non-evil twin. So when you modify the one, you have to take steps to propagate the modification. And we showed an example in a previous live coding demo where I retrieved an object from the database. I made changes to the in-memory copy by setting some of the attributes to new values. But then I sort of, in a different variable, reloaded it from the database just to prove that until I actually say save, any changes I make to the in-memory copy are not persisted. So again, it's a really good abstraction, but it's not 100% magical. You have to explicitly indicate when you want the changes propagated back and forth. And in particular, save has to be used to persist. And when you say destroy, even when the database copy is destroyed, you still have an in-memory object. You can't do very much with it, but it's still there as a reminder that the abstraction leaks. And finally, again, if you're looking at an earlier version of Rails, most of the models don't inherit from application record. They inherit from Active Record base. And so in a Rails version less than 5, you'd see something like this, rather than what we've been showing in our examples where we're inheriting from application record. Now, if you generate a new Rails app using Rails version 5 or later, one of the generated files that it will place in your app basically contains just this much. It defines a class application record, which inherits from Active Record base. And the only thing in this class is basically essentially an annotation saying that it's an abstract class, that it has to be instantiated through subclasses. So what is the point of doing this? I mean, application record doesn't do any additional things that are not already in Active Record from which it inherits. So why would the designers of Rails decide that the best practice is not to inherit directly from Active Record base, but to do sort of this level of indirection for application record? What would be a reason to do it this way? Or we could say, suppose you didn't do it this way. What could be a consequence? because this is setting abstract class to true, presumably that must mean that there are times when you would want it to be false. And maybe that has something to do with why you're supposed to inherit from application record. And you're very much on the right track with that. Basically, suppose that there was a bunch of behaviors that some of your models had to have, but other models didn't have to have. It would be very tempting to first put those behaviors into active record base so that multiple models can now inherit from them. But the problem is if you do that, you've now sort of contaminated active record base, and everything that inherits from it is going to get those behaviors whether it wants them or not. So the idea is by creating a sort of indirection class, you could add behaviors in here and have some of your models inherit from that and other models not, but then you wouldn't sort of put those behaviors into the parent class, right? And this is something that in other programming languages, like if you've done Java, for example, this problem doesn't even arise because in Java, classes are generally closed. You cannot add more functionality to a class that's in some library somewhere, but in Ruby, you can. And so there's nothing preventing me from adding stuff into active record base and then inheriting from it, so everybody who inherits gets it. But now the problem is everybody who inherits gets it, even if you only wanted some of those classes to get it. So the decision was made in Rails 5 to say the best practice is inherit from something else, and you could put your own stuff in there, and then things that don't need that extra functionality can continue to inherit from active record base, and everybody's happy. Or you can even have like an application record and a different kind of application record, and some of your models could inherit from one, and some could inherit from the other, but without having to put all that extra stuff into the parent class. So that's the reason. And if you're looking at old code from a Rails less than 5 application, that's why you'll sometimes see inheriting from active record base directly, rather than from this empty intermediate class that doesn't actually appear to do anything useful. That's why. Did you want to?
Yeah, so when your apps are simple, right, this is one of those things where 80% of the time you probably don't need to worry about augmenting functionality across all of your models. But it turns out that as things grow, right, one of the common places, and Rails programmers, they did this obviously because people running into problems, right? And so if you think about what are the problems that you could run into that would require putting code in nearly every single one of my models, a couple things come to mind. One of them is that when your app grows, we'll talk about this towards the end of the class, but it turns out that using multiple databases becomes a relatively common solution to certain kinds of scaling problems. And so you might have code in an application record that says, given some primary key on a model, use this database instead of that database, or let me read all data from one data source and write data to a different data source for performance reasons. Or another common thing is if you deal with email addresses across multiple models in your application, hopefully you don't have to do this, but you might need to normalize certain kinds of data. And so you want to say, every single model, regardless of what kinds of changes I have, I will follow the pattern of don't repeat myself, and in one class, put my own custom app logic that says, here's how I normalize some data. So, most of the time you can get away with not worrying about it, but there are lots of use cases where it's useful to say, let me centralize some source of truth about my application, and this is a great place to do it.
Yeah. And having said that, by the way, it's rare to find someone saying the best practice is X without having somebody else say, no, wait a minute, I have a better idea for the best practice to do that same thing. There was some discussion whether this was the right approach when you wanted to have a subset of models be able to reuse behaviors, but not all of the models. Because remember when we talked about Ruby and modules and mixins, another possible solution to this problem is, well, okay, if there's a handful of models that need to share some behaviors, can't I just put those behaviors in a module and then mix the module just into the classes that need it? So I will let you have fun searching Stack Overflow for the various arguments for and against. There's not always one best way to solve a problem, but I wanted to at least illuminate, what was the rationale behind this random 3-line file that is part of your boilerplate code and yet does not appear to do anything. That's why it's there.